Yeah, the experiment is done and it is time to look at your data. This video is a bit more instructional than explanatory. This is because data quality control, known as QC, is often not taught in statistics courses, because you usually work with clean data in class. But in real life, it is different. In case you're working with persons, all must be anonymized in accordance with the law. That is a special topic. So, the first thing to do for all kinds of data is to make a description of every variable. What does it mean and what are the units? Was that concentration measured in grams per liter or in moles per liter? In, for example, SPSS and in Excel, you can write that information on a separate tab, so it won't get separated from the real data. This is in SPSS, and here is an example in Excel. When you're done, you copy your original data file and store the original not to be touched again. You work further with your copy. Maybe you need to compute some derived variables first. For example, you collected a person's height and length and now you compute their BMI, body mass index. Use a computer to do this for you and add the calculation and the units to the other list. Now comes the fun bit, visualization. Visualization, so making graphs, is the most important tool in this phase. Are the data in the correct range? Are there any weird outliers? Do you see strange patterns? Visualize your data in any way you can. Step 1 is called sanity check. For example, you see here data for baby's birth weight and their mother's age at the time of birth. Let's first look at the mothers. There seem to be a few teenage pregnancies and a few mothers over 40. So that seems okay. Birth weights are mostly above 2 kilo, but few even below 1 kilo. So maybe premature birth? If only full-term pregnancies were supposed to be in your data, check these again. On average, the birth weights seem a bit above 3 kilo, so that is fine. Heaviest around 5 kilo. And if there is any pattern, it is that older mothers get heavier babies. Also fine because in line with the literature. In some variables, you may find outliers. If measurement outcomes were collected manually and later entered into your spreadsheet, maybe a decimal separator was incorrectly used, such as a comma instead of a dot, or another mistake was made when entering the data. Or some birth weights were measured in kilos and other in pounds or grams. Check every outlier. If the values seem illogical for this variable, check your logbook to see whether there is any explanation. Was the sample dropped at some point, or was that one plant eaten by rabbits? Something like that. If that is the case, make it a missing value. No data is better than bad data. Remember to do this in your copy file, not the original. If all your data seem all right and the outliers are most likely just very high or very low values, well, you may have to think later about how to deal with the outliers, but now we just do quality control. Be sure to visualize every variable and preferably in multiple ways. If you know of patterns that have to be in your data, check them. Grown-ups are taller on average than children. In patients, date of diagnosis should be later than date of birth. Check it all. Use as much as possible visualizations that show every individual observation. Look at these box plots. All 3 data distributions result in the same box plot, but none of them is a nice normal distribution. box plots are not very useful in this phase. If you have to go through multiple steps of cleanup, you may want to store multiple versions of your data file. Be sure to keep track in your logbook of the steps you take, the naming of your files, and maybe reasons you have to discard data points. When you're all done, all your data look sensible and are neatly described, you can continue to the analysis phase. Have fun!